Hi, my name is Sam Gallagher,
And my name is Nate Marks.
and we are doing the facility layout for an electric vehicle assembly line. In our video today, we will discuss the following agenda. We will let you know about our previous progress in 481, define our new scope, our problem statement, the design we followed, some economic decisions that were made, our recommendations to our client, and finally some possible impacts our project may bring. Previously, in our 481 class, we had performed a literature review to acquire the necessary background dealing with electric vehicles. We also designed and analyzed the battery pack assembly process for Sharpell's vehicle. We provided recommendations for layout and process solutions of the battery pack assembly and began planning the next stages of the project development in 482. Sharpell Technology wants to create a high-end, fully bespoke electric car. Though the company is still in the design phase of the vehicle, they have begun talking to investors about the manufacturing and assembly of their future electric vehicle. With little knowledge about facilities planning, they need assistance with the design of their manufacturing assembly line. Right now, they plan on producing around 150 cars in their first year, with the hopes of growing to producing 400 high-end cars by their fourth business year. Our problem statement, therefore, is Sharpell Technology needs to determine the manufacturing processes and required facility space for the assembly of an electric car in California. Because Sharpell Technology is still in their developmental stages, we were tasked with determining the assembly process of an electric vehicle. We decided to take the systematic approach of facility planning to come up with a solution to our problem and begun looking at the big picture by determining the various departments associated with the assembly of an electric vehicle. The departments we created included the chassis and battery pack, the powertrain, suspension, auxiliary systems, the body and wheels, the CPU and wiring, and finally the interior department. Then we researched what steps would need to take place within each department.
First, we started with a basic flowchart of the vehicle assembly process. It begins in the chassis department with the delivery of an outsourced chassis where it is mated with the battery pack. Next, it moves to the powertrain department where the motor is first installed, then the gearbox, then the controllers, and finally the axles. After the powertrain department, it moves into suspension, where the upper and lower A-arms are then placed on the vehicle, the uprights with the bearings are installed, the shocks are installed, and then the brakes are installed. After suspension, it moves through to the auxiliary systems, which are the radiator, the power steering, the brake lines, and then the cooling system and fan. After auxiliary, the body and wheels come up. The body panels are installed, and then the wheels are put on the vehicle, and it now becomes a rolling chassis and can be maneuvered around without a push cart. After the body and wheels are installed, the CPU and wiring are put into the vehicle. This comprises of the main CPU, as well as the internal wiring and the dash wiring. Lastly, the car moves to the interior department, which is the most time-consuming department due to the fact that this is a luxury electric vehicle. The interior department consists of an insulation layer installation, a dash and vinyl leather installation, a carpet installation, a console installation, inner panels, and then the finishing trim. This is a bird's eye view of the same flowchart that we outlined in the previous slide. All of the steps are the exact same. It's just a good visual representation to show the relationships between the departments in a linear layout. It also includes a few quality checks that were discussed with our client. Once the steps of the assembly process were finalized, we then determined the times each task would require to determine the ultimate number of workstations needed at each process. This also helped us understand the bottlenecks, as well as the approximate employee requirements for the facility. Along with each workstation, we determined an estimated square footage needed based on aisles, equipment, and the size of the car itself. Based on our client's 400 car output after 4 years and our total times, we determined a takt time of about 9.4 hours per car, which is just over 1 8-hour shift. Once the production analysis was completed and we had our calculated times, we then understood the approximate number of workstations required for each function within the system. This allowed us to begin a visual representation of the assembly process in SketchUp. Here is a quick bird's eye view of the assembly process. Here we will have a SketchUp walkthrough of the model we created. We are currently putting the finishing touches on the final assembly layout. As you can see from the SketchUp model, all of the assembly processes are standard between the cars produced up to the interior department. Therefore, only one workstation is required for each process until the vehicle reaches this point. Once the vehicle reaches the interior department, the time for each function within this department is variable, but it will definitely take at least 1 day to move through the entire department. Furthermore, this is a bespoke luxury vehicle, which allows the customer full customization of the interior design. This will likely require special components as well as tooling within these interior workstations. Therefore, we recommend 4 workstations for the entire department.
One major decision that must be made when creating a facility is what mode of material handling will be used. We wanted to do an economic analysis based on 3 options: an assisted push cart, a conveyor system, as well as an AGV system. We had to consider the output Sharpell was projecting to manufacture each year, which was relatively low. In many assembly lines with huge outputs, push carts would not be a feasible option based on the speed required between each station. However, because time between stations would not be a huge factor, our economic analysis showed that an assisted pushcart system would be the best economic option for Sharpell technology to implement for their material handling of the assembly line until the vehicle was on the moving chassis. With the creation of our project, we did have some impacts that we needed to consider. First off, we needed to consider the social impact, which in this case was a positive one. By creating a new manufacturing plant, we would be therefore creating jobs for citizens of the nearby town which we would select. By keeping the output low and relying on human labor, it should be welcomed by the working class. Also, another impact that must be considered is the environmental impact. We advised Sharpell Technology that due to his company striving for a totally electric vehicle, he should try and keep a green mindset in selecting manufacturing machines. This, therefore, would maintain the company's image as an environmentally friendly vehicle manufacturer. Finally, we would like to thank you for your time, and we look forward to meeting you and addressing any questions you might have next week. Thank you.